the first four examples are the ones that are going to be on your test, okay? So real quick here for the notes, number one, you must make equations. If you don't make equations, I'm giving you no marks. So you can kind of go what we call caveman and just try and guess the numbers, guess and check, and plug it in. That's fine, but you're getting no marks for that. You got to make equations. So you're getting marks for your equations, your marks for solving, marks for the correct solution. What you also want to do is you want to read the last sentence. Oops, read the last sentence to find the variables / understand what we're looking for. Okay, to understand, whoops, my bad. Understand what we need to find. Okay, now the easy questions, we usually cook these up pretty good, and the ones you're going to have are cooked up where you have to find both items. Okay, and that's why in the last sentence, it'll tell you both items you're trying to find. On the harder examples, they'll just explain one item you're trying to find. But you have to understand what the other item is because you need that for your equation. You're going to have two variables in each equation. Another part that's really important is you need to make a legend. And for a legend, it can be something like x equals the larger number. Okay, so kind of explain it. Now sometimes I like to use letters that are very descriptive if I can. So for example, J equals the number of jackets. I mean, that's going to be really simple, isn't it? Okay, the letter helps you understand which variable keeps them separate. So you got to make a legend. Some teachers call this if-then statements, and I'll show you what an if-then statement looks like. If/then. Okay, but I personally believe that if you use more descriptive variables, it makes it so much easier for you. Okay, so using descriptive variables really helps. Filing cabinet, filing cabinet. Filing cabinet. Yep, awesome, perfect, thank you. Okay, so if-then statements. So the only reason why I introduce if-then statements is teachers in higher level courses might say that you have to. I want you to know what they are. That's all. Okay. So let's read the first question here. All right. Sum of two numbers is 162 and the difference is 48. Find the numbers. So let's underline a few things. First of all, sum. What is meant by sum? The answer to an addition. Okay, so sum is an answer to an addition. So you got to have one equation where you're doing an addition. What does difference mean? Subtraction. So one equation must be a subtraction. You've got to look at these key math words and understand what they mean because they're going to help you make the equation. Okay, let's read the last sentence. Find the numbers. Okay, so the two numbers are going to be our variables. Okay, now they're not the same, so since they're not the same, you're always going to have one number that's larger and one number that's smaller. Does that make sense? Right? Because if you got two of them, you got to have one larger and one smaller. So we can use that idea. That's kind of an important thing to understand. One number's got to be larger, one number's got to be smaller. That's how our numbers work, if there's two of them. Okay? So that's how going to help us make our legend. So for our legend, I try to avoid, okay, like X and Y are good, so I'll use X and Y for this one, but then I won't use X and Y for the next one. Okay, so we'll do an if statement. If X is the larger number, and I kind of go away from English here and go into math. So if X is larger number, see how I cheat? Okay, I kind of don't write down the word the. Do you have this or not? Do you want a copy? Do you want a copy? Okay. So I kind of write shorthand a little bit. Just rip it out. Just, for now, just use it, okay? Anyone else see a copy? Okay. So I just kind of write some shorthand to help me. So that's the if statement. So if that is true, then what would y have to be? Y is a smaller. Okay. And for the difference, for the subtraction, it's really important that you know which one's larger. Why? Well, what's the difference between 7 minus 5 and 5 minus 7? Yeah, 7 minus 5 equals 2. What about 5 minus 7? Negative 2. So subtraction is the important one, and subtraction is the one where you can make a mistake. It's the only one where you can make a mistake. So with subtraction, what's the key idea that you have to remember? Larger number must be first. And so, no matter what, when you're doing your subtraction, you're identifying the larger number. And if you get it wrong, sometimes it can hurt you. Sometimes it can't, sometimes it can. It kind of depends on what the other equation is that you're making up. Okay, so let's look at the very first sentence and make an equation. The sum of two numbers is 162. How are we going to write these two numbers adding up and equaling 162? Oh, I just said it. These two numbers adding up equaling 162. What do I have to write down for my equation? This is a sum, though. That's the first equation right here. The sum of two numbers is 162. No, the sum. That's an addition. No. Just focus. You're going 10 steps ahead. One sentence. The sum of the numbers is 162. James? Nope. Sum. S-U-M. Addition. Elvin. Yes, you guys are thinking 10 steps, like make it easy. X plus y equals 162. That math sentence clearly and explicitly explains what that English sentence meant. Okay. Now, I know you guys haven't done word problems last year with COVID and stuff. You do not have a lot of practice. That's okay. We'll work through this. All right. What about the second sentence or the second part? Their difference is 48. Well, you saw the sum part. What would be the difference part? X equals 48. Okay. So that math sentence explicitly describes the second English sentence, or second part of it. Okay. So one's x plus y equals 162. The other one's x minus y equals 148. One's a sum. The other is just a difference. So now we can go solve. So let's eliminate. Go for it. Okay. The x's are all ready. Do you guys want to add or subtract to get rid of the x's? Subtract. You're right. Good. Okay. Go ahead. Do a subtraction. Quit staring at me. Do the math. You need to do the math. Let's go. This is called your practice studying time. How many y's you got? Ooh, yes you do. You got 2 y's because you have y minus negative y. Okay, so to take away a negative means you're adding a positive. So really, you would change that to y plus y. Okay, solve for y. Okay, so you got y equals 57. Okay, over here real quickly, find the x. Which equation you want to substitute into? Chase says the top one. Go ahead, substitute into the top. I'm going to be tricky. I'm going to substitute in the bottom. We'll see if we get different answers. Okay. Do you guys use the top equation? Did you get a different answer or the same? You got the same. That's how these things work. It doesn't matter which one you choose. If you do the math correctly, you will get the exact same answer. So now this is a word problem. So we've got to finish with either a short sentence. Okay. So a short sentence. So what would be a short sentence? Oh, don't think so hard. Come on now. The two numbers, or you know what, take away the word two. That's too lengthy. The numbers are 57 and 105. And then put it in a box so Mr. Barker marks it all correct. Okay. So just a short thing, just describing it. And what you should do is you should reread this. Find the numbers. So now you know how to make this sentence, right? The question's saying or telling you, find the numbers, so your sentence should say the numbers are. Okay? So the last sentence helps you out with that. Kermit? No, so this is where it's a little bit weird now. With this system, we aren't finding points, we are finding actual numbers, we're finding actual things. So we don't want to use the brackets and the comma. We want to say what they are. So down here, we're going to be looking at the width and the length, okay? The length and the width. So we want to say the length is, the width is. Here we'll be talking about dimes and nickels. So we'll say dimes are, quarters are, okay? We're finding specific things now, not a data point on a graph. So we're moving from graphing to real world situations. Okay. All right, any questions? Okay, read example number 2, underline important stuff. Go for it. Read, underline important stuff. What did you underline? Sum, exactly. What else did you underline? Yeah, the larger exceeds twice the smaller by 2. This is a really, really weird one. What it actually is, it's actually a difference equation. And this is probably, I'd say, the hardest one to work with right there, okay? So I'll help you through that one. The one on the test is more similar to the very first one, okay? And then the last question is, what are the numbers? So the first example, I showed you how to make a if-then statement. Now I'll show you how to make a legend. It's really, really similar. Okay, so for your legend, you can just say X equals the larger and Y equals the smaller. Pretty simple, isn't it? Who wants to make a more descriptive legend, though? Oh, Alex does. Perfect. What letter can we use for larger number? Capital L equals larger. Wow, that's a good idea. And what letter could you use for smaller? Okay, so here's the deal. I try and avoid the letter S and the letter L or lowercase l. Notice how I made the capital L. And also the Z. Why? Yeah, 5, a 1, and a 2 sometimes. So I always try and avoid those numbers because they can be confused with numbers and also you're working away and you lose track of what you've done. All right. So those numbers I do avoid using. So what else could you use? Sometimes you can use the second letter. Okay. So I'll use the second letter. So I'm going to use M and L just because I want to show you different ways of doing things. Okay. First equation, the sum of two numbers is 56. What's that one going to be? M plus L equals 56, or X plus Y if you want to use X plus Y. Okay? So 1 smaller plus the larger. Now the second one, here you go. The larger exceeds twice the smaller by 2. So we have a subtraction. Okay. Which one's bigger? The larger or twice the smaller? Yeah, the larger. It exceeds. So that means it's bigger. So we got to put L first. In a subtraction, you must have the higher number first. Let's write that down. Or did I write that down up above? Yeah, I did. Good. Okay. So M plus L equals, okay, so 2L minus what? How would you write twice the smaller? Some people are thinking, I see in your eyes. What do you think, Alex? Yes, you do. Trevor, what do you think? Take a guess.
Put the M there?
Yep, but it's twice the smaller. Not M squared, because that would be the smaller squared. You're on the right track, though.
2M?
2M, yeah. Okay. So twice the smaller would be 2M. And what does it exceed by? 2. Okay. All right. Do you guys see how I screwed things up here? What did Mr. Barker screw up? What should he go back and change? Off the bro?
You put the M before the L.
Yeah, so if these don't line up, that's going to be hard to do elimination. I mean, you can do substitution if you want. So Mr. Barker's going to go back and fix that. That's why he works in pencil. And I will just have L plus M. Okay? All right. Do you guys want to do substitution or elimination? Go for it. Solve it. Go. Quick, quick, quick. Quick like a kitty cat. Let's go. Okay, so I got the larger number is 38, the smaller as 18. Did you guys get that as well? Yeah. Awesome. Okay, so then read the last sentence. What does the last sentence say? What are the numbers? So what is our answer going to say? The numbers are, right? We're going to reflect that last sentence. The numbers are 18 and 38. Okay? And you can just use a comma. You can use the word and if you want. That's fine. I'm just super lazy and I write commas instead of the word and. Okay? But don't think of it as a data point. Does that make sense? It's not more a data point. These are two separate things. Yeah.
Does it matter which one you prefer?
I try and go numerical because you should be able to identify which one's smaller, which one's larger, and the question's kind of separating those. But I wouldn't mark it wrong. Yeah, I won't mark it wrong. Okay. And the weird thing is, so if you go back here, and if I actually in this question wrote y first, then guess what? Without knowing it, I would have flipped the y into the larger number. Okay. That's hard to do when you have 2m, right? But if I did flip it, then you get some weird stuff. So for difference equations, you've got to make sure you have the larger number first, okay? If not, you might unknowingly make that swap, okay? Any questions? Okay, classic here. This is a classic. Now, just so you know, on your test, you're going to have one question like example 1 and 2, one like example number 3, and one like example number 4, right? Those are the ones that I have on the test. So the perimeter. What do you know about the perimeter of a rectangle? Well, this is what I encourage you to do on a test. I encourage you to draw a quick rectangle. Okay? Draw it. Now label it, just with the capital letters. So the bottom will be the length, the top will be the length. It could be the width, but I decided to do that. And then we'll have the width as the other location. How many lengths and how many widths are there? 2. That's so important to see. Okay, if you have 2 widths and you have 2 lengths, and that equals the perimeter. Okay, now normally you're used to seeing P first, but if I write it flipped, it's more like general form now, isn't it? Okay, or standard form, to be honest. Okay, so the very first sentence, the perimeter of a rectangular garden is 19. So right away you know the first equation. What is it? That's right, 2w plus 2l. You have to know that as soon as I say perimeter of a rectangle, you can write down 2w plus 2l. And then the word is often indicates the equal sign with word problems. So equals 19. All right. So here's a tough one now. Triple the length is half a meter longer than 5 times the width. So which one's longer? Triple the length or 5 times the width? Yeah, so if you cross this out, triple the length is longer. It says that in the words. Okay, so that has to go first in our subtraction. Triple the length will be what? 3L minus what? 5W. Okay, and what does that equal? Half a meter. That's strange. Should we write the fraction or the decimal? Decimal. Yeah. Okay, so 0.5. Any ideas on what else we can do to make this easier for us? German? Yeah, the 2W and the 2L up top, we can swap those around. So then they line up better with below. So we would go 2L plus 2W. Addition doesn't matter. Okay, but the subtraction's set. All right. So, can we eliminate right away? Nope. What do you guys want to eliminate, your W's or your L's? Vaughn, you choose. W's. So you got 2 and 5. What would be the LCM? 10, exactly. So go ahead. What would you do to the first equation? Multiply by 5, and what would you do to the bottom equation? Times by 2. Go ahead, get your W's the same. Probably need your calculator to do some simple multiplying here, which is fine, right? Okay, you should be doing the math now. Solving, please. Don't be looking at me. Pretend this is the test. Yes.
Does it matter when you find out? Does it matter what version you go into?
No, yeah, you can choose the top one or the bottom one. Once you're at that point, either will work.
But you know how we change them? Like 10 L's.
Oh, yeah, you could use these too. Yeah, and I only do that when I have fractions. Yeah, but because, and the only reason why I don't is because these tend to be simpler with smaller numbers. Okay, but you totally could, Jordan. It is really your choice. So I got length of 6. Who else got length of 6? Awesome. So substitute in now, find your width, do whichever equation you like. Okay, so I'll be honest with you. I totally got to this point here, and I'm like freaking out because I'm like, oh, -5W, But then I remembered, you know what? That actually is really common when you're solving word problems with systems. It's actually common to get like a negative in front of a negative number in front of the letter. But what happens is this side also becomes negative. And so then when you divide, voila, your answer is positive, okay? So it's a positive 3.5, which you have to have. You cannot have a negative measurement for length or width. You can't have negative measurements. All measurements are positives. Okay, good. So what is my answer going to look like now? Well, you can do a whole complete sentence, or at this stage of the game, you can just simply say length equals 6, width equals 3.5. And 3.5 is okay because we were given a 0.5 measurement, okay, and we can measure with decimals for meters. We probably should say meters and meters. Did they tell us meters? Yeah, so we should say meters and meters, okay? Again, I like to have my answer in the bottom right side, okay, just easy place to find it, okay? So sometimes we can move away from the sentence if we have specific things other than numbers, okay? As long as you kind of identify. What I don't want to do is I am not looking to go and read and find down your answers and figure what L and W mean. Okay, I want you to tell me you know what they mean, right? Communication skills. Even though we don't use full English, you have to communicate your ideas and explicitly explain what it is that you found, okay? And it says right here, find the dimensions of the garden. That's why I needed to write that, okay? Always look at the very last sentence before you write your answer, not like I did some on remote control here. Any questions you guys have? Okay, next one. I love these ones. Coins. Okay, so piggyback, read it, underline the important stuff. Go. Okay, so a couple things that are important. Number one, dimes and nickels and how much he has. And then 23 coins together. Okay, so what letters can we use? What would be descriptive letters? Exactly, right? D and Q. Lowercase or capital, does it matter? No, okay? So I'm just going to say D equals the number of dimes. So that's how many coins I have, which is a little bit important because it's different than what the value of dimes is that I have, okay? And the other one would be quarters. Q equals number of quarters. Okay, so the other thing you need to know is the value. So the value equals, the amount, the value equals the value of the coin times the quantity. Right? So for example, if you have 2 dimes, that'd be 2 times 10 cents. You'd have 20 cents. Do you guys agree with me there? Right? If you have 5 nickels, right? Or sorry, if you have 4 quarters, that'd be 4 times 0.25. So you'd have $1. Took me a while, a second. Okay, so the first equation is simple, 23 coins together. That means the number of dimes plus the number of quarters equals how much? 23. That's how many coins you have. Okay. The next one is going to be the value equation. So this one here is a quantity equation. The next one is going to be your value equation. What's the total value of coins that you have? $4.55. Okay. So, what's the value of a dime in dollars? 0.1 times the number of dimes. What would be the value of all the quarters you have? 0.25 times Q, the number of quarters you have. Okay. All right. So here's where it kind of gets a little wishy-washy. There's several different ways of solving these things. One way, I'd like to try and avoid working with the decimals. And the reason why is because students often lose their decimals. Okay. And so what I like to do is I like to times this one by 100. So what happens then, when you times it by 100, is you get 10D plus 25Q equals 455. So your decimals are gone. And why does Mr. Barker do that? Because often I see students lose their decimals. That's the only reason why I do it. So if you don't want to, you don't have to, but I strongly encourage it. Now, let's multiply the top equation by a number so we can eliminate either D or Q. Which one do you want to eliminate, Manu? So what should we multiply by? So what should we multiply the top equation by? 10. Awesome. So multiply this one by 10. And often in the olden days, we never used calculators, right? And that's the other reason why we like the get rid of the decimal trick. Okay. Add or subtract, Manu?
Subtract.
Good. Go ahead, do a subtraction. So remember, I told you often you get two negative answers, which is fine, because then when you divide the negative by the negative, you get a positive result. Okay. Now, once you find Q, you have 15 quarters. What's the easiest equation to work with? Probably this one right here, right? So D plus Q equals 23. And so you get D plus 15 equals 23. D equals, I am not doing math this morning, I'm on strike, 8. Okay. So read the last sentence. It says, the last sentence says, how much of each kind of coin are there? Or how many of each coin? So what's our answer going to look like? Yeah. So dimes equals 8, quarters equals 15. Or you could do more what Jordan said and just say 8 dimes and 15 quarters. You don't even need an equal sign. Okay, there you go. Or you could do a longer sentence. Don't care. All right. But you're telling me you knew what to look for, you found it, and this is what it is. Okay, you have to explicitly say that. Any questions? This is another good one, but I'm going to leave example 4. Okay, so on the test, you're going to have a question like number 1 and 2, a question like number 3, and a question like number 4. It's just going to be 3 questions on the test, one of each type. Okay? Pardon me?
1, 2, 4.
Well, 1 and 2 are the same. So it's going to be a numbers one, a perimeter one, and a money one, for sure. Okay? So to help you out, what I've done is don't do the textbook work that's on the outline. You want to do the word problems part 2.